Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. In this video, we're going to take a look at how to simplify complex rational expressions. So let's get started. Now, we know what a rational expression is. That is when you have the value P over Q, and of course, I don't want that, and Q does not equal 0. We've seen this before. Now, a complex rational expression is where the numerator and or the denominator contains a rational expression itself. So if we had to talk about this hypothetically, we would do P over Q over, P over, Z or something. This would be an example of a complex rational expression. And so in this video, we're going to learn how to simplify these. So let's go ahead and take a look at our example. We have here 2 over x squared, that's kind of big, minus 1, all this divided by 3 over x plus 1. So the first thing we want to do is that we want to put these two numbers side by side. It's hard to deal with them when they're in this rational expression fraction type form. So this right here is going to lead to a slight change. If you just take a look right here off to your right, it'll be 2x squared minus 1 divided by 3 over x plus 1. Of course, that's kind of crooked, but you get the point. Let me move that up a little bit. 3 over x plus 1. So now we have things side by side. But as you know, whenever you're dealing with a rational expression for the purpose of division, or when you're dealing with fractions for the purpose of division, if you flip or if you use the reciprocal of the second term, that's the one to the right of the division, you could then create a multiplication problem. So that leads to the following. Just draw an arrow so we don't get lost. 2 over x squared minus 1 multiplied by x plus 1 over 3. Now we're getting close. Now what we need to do now is that we need to factor this x squared minus 1 here. And we're going to do that on the next page. So we were left with 2 over x squared minus 1. Multiply that by x plus 1 over 3. Let me check that to make sure. Yeah, that's correct. Now, we're going to factor, like I told you before, this guy right here and see what we can get. And so when we do that, it's just a perfect, factor of squares, perfect squares here. It's not that complicated. We end up with the following. We end up with 2. So let me give you a different color here. We end up with 2 over x plus 1, x minus 1, multiplied by x plus 1, x plus 1, let me scoot that over a little bit, x plus 1, x plus 1 over 3. And so now it's just a matter of dealing with everything. So we already know that the x plus 1 here at the top is going to eliminate with the x plus 1 over here. And so when we do the final answer, we're going to have 2 over 3 x minus 1. Now there are some constraints that we have to consider here because, as you know, the denominator cannot be 0. This means that x cannot equal, let's see here, it cannot equal 1 or negative 1. As long as we put in place that constraint, we should be okay. So our final answer is going to be 2 over 3 inside parentheses x minus 1 close parentheses. And this is our answer. And of course we could further simplify this if we wanted to, but generally we can stop right here for our purposes in this video. So in this video, what we learned was how to deal with and how to address simplifying complex rational expressions. And so a complex rational expression is where either the denominator or the numerator contains a rational expression. And so in our example here, you can clearly see that we meet that criteria because we have a rational expression in the denominator right here, and also a rational expression in the numerator. And so the first thing you do is you want to put the terms next to each other, side by side. So you remove the fraction sign and you use the division sign here. And after that, as you know that whenever you do division with fractions or with rational expressions, if you use the reciprocal of the second term, the term to the right of the division sign, you then have a multiplication problem. And so that's what we did right here in this step right here. After doing that, we simplified, I'm sorry, we didn't simplify, we factored whatever was possible for us to factor. So in this example that we did in this video, we were only able to factor the x squared minus 1. That's what we did. We factored it because everything else was already in its lowest common denominator, or the lowest common value, if you want, whatever you want to call it, or already could not be factored any further. And so when you do that, it's just a matter of removing whatever values are in the numerator and the denominator, and then whatever is left over is your answer right here. Now, one thing that you have to be careful of, and we haven't talked about this a lot in prior videos, is that there are certain constraints on the denominator. As you know, it cannot be 0. And so in this example here, x cannot be 1 because 1 squared minus 1 is going to be 0. And you cannot have 2 over 0 here. And also, x cannot be negative 1 because, again, you have the same problem. Again, this is a constraint from the beginning. And so, again, this also applies here because you can see here 1 minus 1 will be 0, and 3 times 0 is 0. But for the negative 1, it comes from this guy up here. All right, so my name is Darren Thomas. I hope this video was useful for you and that you were able to understand what is happening with simplifying rational expressions. I'm the Director of Educational Research Techniques. Thank you for watching. Take care.